Hi, my name is John, and I had some requests for students with taking advanced mathematics, usually reserved for Algebra 2 honors. It could be college prep, depending on the teacher, and they had some questions on Chapter 16, Section 1, with the problems. Let's get started right away. Before we do the Chapter 16, Section 1, I want to go over events, what an event is. An event is something that happens. So on the first page, you have a pin like this. It could either land on its flat side, or it can either land like this on its side where it's going down. So there's two events possible. There's also a third event that's possible, which is extremely unlikely, but it could literally land on the tip. Supposing that the floor is made out of cork, it could actually land like this. It has more probability, but assuming that we don't have this as a probability of landing on its tip, it will either land this way upright or on the side. Okay, so we're looking at probably, I don't know what the events of these two are. But this is probably approximately 0, okay, or null. So let's get started with example 1 to make sure you guys understand what the problem says. This is, I believe, on page 598. Okay, so make sure you understand example number 1. Suppose that a die is rolled. A die means one dice. Dice means two. It's plural. Give the sample space for the experiment, then find the probability of rolling a prime number. So the sample space is the events that, all the events that are possible, like on its head or on its side. On its head, on its back, same thing. So the sample space is 1, 2, 3, 4, 5, and 6. And part B says, find the probability of rolling a prime number. Probability of prime equals question mark. That's what we're looking for, the probability of a prime number. Well, obviously, the probability of a prime is equal to the total events possible, which is 1, 2, 3, 4, 5, 6. There are 6 events possible. The prime numbers are 2, 3, and 5. 1 is not a prime number, neither is 4 or 6. So it's going to be 3 out of 6, which is 50% or half. So it's 50% likely that you're going to roll a prime number. Okay. Some of the things that happens is probability of two events happening. The general rule, if the probabilities are equally likely to happen, is the probability of A or the probability of B is equal to the probability of A plus the probability of B minus probability of A intersection B, where A and B both occur. The reason why that happens is because sometimes A and B intersect, or they are not mutually exclusive. There is some inclusivity between these two, as noted in page 599, the top Venn diagram. So if that happens, the probability of A plus probability of B minus probability of the intersection. So I'm going to actually show you what actually happens. So in this book right here, as you can see, is the probability of A plus the probability of B minus the probability of A and B, where that's where the intersection comes out on the Venn diagram. So that's what you have to keep in mind. If A and B are mutually exclusive, then probability of A or B is equal to the probability of A plus the probability of B. That's when the it's mutually exclusive, which means that they have no common sample space. Also, probability of A complement, right there, that's called a complement, is equal to, let me get this a little bit closer like this. Okay, so you guys can see better. Probability of A is equal, A prime, or the complement, is equal to 1 minus probability of A. And that's pretty simple. You learned this last chapter. So let's get example 2. There's 3 parts to it. As shown below, a standard deck of playing card consists of 52 cards. 13 cards are with 4 suits: clubs, spades, diamonds, hearts. Most of you should know what the cards do. Also, there are jack, queen, king cards, face cards. So face card does not include, face card includes jack, queen, king. It does not include ace nor 10. The reason why it doesn't include ace nor 10 is because obviously they don't have a face, and that's why it's not called a face card. What's the probability of getting a black ace? Probability of black ace. Okay. The probability of a black ace, how many black aces are there? There are 2 black aces. That's equal to 2 black aces out of total cards, which is 52, which is 1 out of 26. I believe that's the answer in the book. Yes. Part B says not a black ace. So you have to use a complement rule. Probability of black ace and not black ace is equal to 1 minus 1 over 26, which is equal to 25 over 26. Okay? And that should be sufficient for the complement. A diamond face card. Part C. Probability of a diamond face card. How many diamond face cards are there? There are the king of diamonds, the queen of diamonds, and the jack of diamonds. So there's going to be 3 out of 52. And that's it. I believe that's not reducible. Yes, it's not reducible. So that's the solution set for example number 2. Example number 3. It looks something like this. Suppose a red die and a white die are rolled. What is the probability that some of the numbers showing in the dice is 9 or 10? Probability of 9 or probability of 10? That's what we're looking for. Notice the probability of a 9 or 10 is the same thing as, using the formula, it's the probability of a 9 plus the probability of a 10 minus probability of 9 intersection 10, where they both occur. The probability of a 9 is, you have to list the probability of a 9. That will help you. It's 7 and 2. Oh, you can't have 7 and 2 because you can't, excuse me, what's going on? Okay. So you can't have a 7 and 2. The reason why you can't have a 7 and 2 is because there's no 7 faces on a 6-sided dice, obviously. So you could have a 6 and a 3, 3 and a 6. That's 1 pair. 5 and a 4, 4 and a 5. That's 2 pair. Is that it? Yeah, that's it. So the probability of a 9 is 4 out of 36. Probability of a 10 is going to be a 5 and a 5, 6 and a 4, 4 and a 6. So there's 1 pair, 5 and a 5, 4, 6, 6, 4. That's 3 out of 10. 3 out of 36. The reason why there's 36, by the way, is because you have a 6-sided dice. That's how many events are possible in the first roll. The second roll, you can have 6-sided dice. So 6 times 6 is 36. So you can have 1, 6, 1, 5, 1, 4, 1, 3, 1, 2, 1, 1. And then you could have 2, 6, 2, 5, 2, 4, 2, 3, 2, 2, 2, 1, dot, dot, dot. And so you will have a total of 36 events possible. Minus probability of 9 and a 10 at the same time is impossible. Okay, so these are mutually exclusive events, obviously. And so it's going to be 4 plus 3 is 7 over 36. Is that the answer? Yeah, that's the answer. So we're done. Example number 4. Suppose you toss 3 coins. What's the probability that exactly 2 of them tosses result in heads? What's the probability of exactly two heads are, so what's the probability of two heads given you toss 3 coins? And they want you to use what's called a tree diagram. So here's what the tree diagram says. On the first toss, you can either have a heads or tails. On the second toss, after the heads came out, it could be heads or tails. If the first toss came out to be a tails, it could be heads or tails. And then the third toss is going to be heads or tails on each one of these other events. And so on the 3 tosses, you can have heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, etc. So you can have many different ways. That's called a tree diagram. These are called the branches right here, and the end result right here is this is called a leaf. And of course, when you have a tree, you can have the leaves of branches of a tree. Okay. So the first event is heads, heads, heads. That would actually be one of the leaf that comes out. Okay. I'm not sure if you can see this, but it should be heads, heads, heads. So suppose 3 coins are tossed. What's probably that exactly 2 of them? Oh, here it is right there. Exactly 2 of them are heads. So let's see what happens. You can have heads, heads, tails. Heads, heads, tails. You can have heads, heads, tails, heads. There's the first part. You can have tails, heads, heads. Oh, there's only 3 of them possible. So the probability of 2 heads, exactly 2 heads, is going to be 3 out of how many events are possible? Well, the first event, you can either have heads or tails. That's 2 events possible. The second event is heads or tails times. The third event is 2 heads or tails. So 2 times 2 times 2 is 8. The event is 3 out of 8 that possible that you're going to have exactly 2 heads. Most of the written exercise problems are pretty simple, so it shouldn't be too difficult per se. I'm going to use a back now. Let's actually do some of these problems and try to get as much done as possible, okay? So for the written exercises, 1A, suppose the card is drawn from a well-shuffled standard deck of cards. Find the probability of drawing each of the following. 1A, probability of a black card. Well, obviously there's going to be 26 black out of 52 cards possible, which is going to be 1/2, and that seems to be fair. Okay. A spade, probably a spade. There are 13 spades available divided by 52, which is equal to 1/4 if we reduce that fraction. Probability of spade, not spade, is equal to 1 minus 1/4 is equal to 3/4. And now I'll let you do number 3 and number 5 by yourselves. Let's look at number 7. It's an interesting question. New York City is divided into 5 boroughs: Manhattan, Queens, Bronx, Brooklyn, Staten Island. Suppose that New York City telephone number is randomly chosen. Explain what the probability that the Manhattan telephone is not exactly 1 out of 5. Probability of Manhattan does not equal 1 out of 5. Explain why. Well, even though you have 5 boroughs of the New York City, Manhattan is the most congested. Manhattan actually is where the Empire State is. The Empire State Building is located. It's where the Central Park is located. It's where used to be the 2 towers. I believe it's called Unity Tower or something now. But anyways, so that's Manhattan. It's an island. It's the most congested island. So the probability of that is probably going to be like 1/2, because there are many people that live in Manhattan. So that's the reason why. What in part B? That's part A. It's not necessarily 1/2. I'm just guessing, estimating that probably there's a lot of people living in Manhattan. What do you need to know in order for the correct probability in part A? You need the density, or how many people there are per square mile. And that will give you how many people that are located in that borough, and that's where you can find out what the probability would be. Let's do number 9. That's a cute little question. 9A. It says, use a table in 601 to give the 36 equally likely outcomes with the 2 dice when the 2 dice are rolled. Find the probability of a sum equal to a 6. You're probably not going to have the book to use when you're actually taking the test, so let's actually try to figure out what the sum of a 6 will look like. The events that comes out to be a sum of a 6 is 1, 5, 5, 1, 2, 4, 4, 2, and 3, 3. You can't have the other 3, 3. It's the same 3, 3. So it's 1, 2, 3, 4, 5. Probability of a sum equals to a 6 is equal to 5 out of 36. Part B, probability of a sum equal to 7. The probability of a sum equal to 7 is 1 and 6, 6, 1, 2, 4, 4, 2, I'm sorry, 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, and 4, 5. And that's 1, 2, 3, 4, 5, 6 events possible. So that's going to be 6 out of 36, which is equal to 1/6. By the way, a quick note, the sum of a 7 is the most highly probable number. Okay? And I think you can do the rest. Number 11, 2 dice. The 2 dice shows the different numbers. So on number 11, find the probability of not equal number. And then we can use the complement of that. The probability, or I'm sorry, the 2 dice shows different numbers. I want to find the probability of an equal number and then use the complement rule. The probability of equal number is 1, 1, 2, 2, 3, 3, ... There's all the way up to 6, 6. So there's 6 of them. So the probability of equal number is 1 out of 6. So probability of not equal number is equal to the complement is 1 out of 1 minus 1/6, which is 5/6. Okay. 13, right? Dice rolled and coin is tossed. I think you guys can do that. Oh, let's do example 15, because I believe some students have problems with odds. What are odds? Suppose that the odds in favor of a National League winning the All-Star game is 4-3. Odds is equal to 4-3. That's in favorable to not favorable. So this is for National League. So baseball, there's National League and American League, I believe. Yeah, of course. So the odds are either favorable to 4 and not favorable is 3, which means that the odds of, what is the question? National League is going to be favorable, in favor, because 4 is obviously bigger than 3. So the odds of winning the National League are favorable, which is greater than 50%. Find A, but probability that the National League will win. Win, National League. Okay. So the probability that the National League will win is the favorable, which is 4, over the total, right there, is going to be 7. I'll let you do part B on your own. Suppose an octagon face number 1. Number 17. We'll do number 17. I'll let you do number 19 and 21 by yourselves, and 23. 17. Suppose you roll 2 dice, each of which is a regular octahedron with faces number 1 through 8. So octahedron is a type of 8-sided solid. What is the probability that the sum of the numbers showing is a 2? Well, the only event possible is a 1 and a 1. And so the probability of rolling snake eyes, 1 comma 1, is equal to 1 out of, the total is, since it's 8 each, it's 8 times 8, which is 64. That's the probability of rolling a snake eyes. What is the probability that the sum is 3? So the probability of sum equal to 3 is 1 comma 2 and 2 comma 1. So that's equal to 2 out of 64, which is equal to 1 out of 32. What is the most likely number to appear? As noted earlier, 7 was the most likely noted number because there was the most combinations of adding up to a 7. As you notice here, and when you get 1, 1, there's only one of them. When you sum is 3, it's 1, 2, 2, and 1. And as you make it go higher and higher, the sum is going to be 8 is the most probability. I'm sorry, not 8, 9. Because you can have 1 comma 8, 8 comma 1, 2 comma 7, 7 comma 2, dot, dot, dot. And you can figure out how many there are. I believe there are 9, but I'm not quite sure. Or 8, I'm not quite sure. Yes, there are 8. I remember the question now. Okay, I'll let you do number 19 by yourself. How about 23? 23 is a pretty cute little question. The letters of Texas are arranged in random order. What's the probability that the letter taxes will be spelled? So you get T-E-X-A-S, 1, 2, 3, 4, 5. There are 5 letters in Texas. And so what's the probability of having it spelled taxes? There's only one way that can be spelled taxes, which is T-A-X-E-S. It's going to be 1 out of. And there are 5 different letters. How many different ways can you permutate 5 letters? Well, it's 5p5. It's from last chapter. 5p5 is equal to 5 factorial. 5 factorial is going to be 120. So that's the end of chapter 16, section 1. So if you have any questions, let me know. The end.